What is a Terralith, and should you break one up? Let's find out in today's Terraform Tuesday. What's up, everybody? It's Ned Bellavance, nedinthecloud.com, and welcome to another Terraform Tuesdays. Today's topic is about Terraliths. A few months ago, I had on Matt Gowie from MasterPoint, and we talked about infrastructure as code in general, and he mentioned Terraliths. And he promised to come back on and dig more into what a Terralith is and how you go about actually breaking one up in a future episode. Well, that day is today. So without any further ado, please enjoy this conversation with me and Matt Gowie from MasterPoint. Well, Matt Gowie, welcome to Terraform Tuesdays. Very pumped to talk to you about Terraliths. Before we get into that, for anyone who doesn't know you, can you tell people a little bit about yourself and what MasterPoint is?
Yeah, sure. My name is Matt. I run the company MasterPoint that you just mentioned. We are an infrastructure as code consulting firm. We really help our clients migrate, automate, and innovate their infrastructure as code workflows. So it's not holding back their teams, really helping them move in the right direction so that when they're at scale, when they're provisioning a lot of infrastructure for a lot of application engineers, they're really optimized to be kind of doing it the best that they possibly can.
So you're seeing this Terraform day in, day out, really molding and figuring out best practices for IAC.
Yep. Yeah, this is kind of our day to day is thinking about Terraform, OpenTofu, and really how do we optimize? What are the best practices we need to put in place? How do we advise clients? All of the content that we put out on our blog is about, hey, what's the potential new tool that we might want to use, or what's a problem that we see consistently that we want to help people avoid? And we're really focused on, hey, what does infrastructure as code look like at scale at a small company? What does it look like at a scale at a company of 5,000 engineers? How do we make this a pleasurable experience so that we can ship infrastructure and manage it without losing our minds? And I think that there's a lot of sharp edges within the infrastructure as code world. There's a lot of different ways that people are looking at things. So we're always trying to look at it from different angles and like kind of come at it and focus on what have we seen work really well and what have we seen fall down.
Well, that idea of how you would arrange things for a small business versus a very large organization is an interesting topic. Maybe something we can get into another time. But another thing that you have mentioned you've seen a bunch of times, and it's a persistent problem, are Terraliths. So can you explain what a Terralith is and why it's bad?
Yeah. We've talked about this a little bit before. This is one of the things that I harp on a lot because it's one of the things that our clients, consistently again and again and again, we run into a lot with clients. And a Terralith is essentially a root module. So the Terraform project that you actually change directory into and you run Terraform plan and run Terraform apply, you can think about a root module. Hey, it has one to many state files. When that state file has become too big. So a Terralith is when you have built a root module to contain too much infrastructure where the problems that you run into are, hey, your plan and apply cycle slowed down because it's actually needing to go out to the cloud and make many requests to understand, hey, what's the current state of this infrastructure that I'm managing? So it's sending 100, 500, 10,000 requests to actually understand what's the state of this infrastructure. And then, the other problems that other than slowdown is like, you can get into blast radius issues where, hey, you have one change to update an environment variable for your application cluster, but you're also upgrading Postgres. Somebody else in your team is upgrading Postgres. And now how do you selectively make that one change that is very low effort or a low issue for maybe one environment, but you don't want to make that other change? And the issues around, hey, you have too many resources within one plan and apply, and you now want to selectively choose which one gets actually applied, what makes it out to your provisioned infrastructure, that gets dicey because now you can't automate as well. So Those are like two of the major issues. There's also issues around role-based access control and who has access to what. There's issues around, hey, I have infrastructure that I want only to run in production, but I don't want to run it in dev. There's a whole host of things. We have a long blog post that breaks down what is a Terralith, what are the problems behind it, what can you do to avoid it,
Hmm.
and yeah, that's it's a fun topic.
Yeah, a couple of things I want to drill into a little more deeply is the idea of too much scope for your RBAC. So is the core idea there, if I'm managing way too much infrastructure with a single root module, I have to grant it permissions to manage all of that stuff? And maybe I want to be more narrowly scoped for each identity?
Yeah, so it's kind of that latter piece there. You kind of you nailed it. I'll give you the example of, hey, you have an organization, you have a few hundred developers, you have core platform engineers who manage the network layer, right? They
Hmm.
provision the VPC. Maybe there's a bunch of VPC peering going on. They provision your security group rules is a really important one, right? You don't want your application engineers to have access and be able to change security group rules, not because they might they're potentially doing anything nefarious, but maybe they just make a mistake and they could actually cause some serious outage in production. But you do want to give those application engineers the ability to manage their database parameters, for
Hmm.
example, because that's something that they're tuning to make their production system better. So if you have all of that in one root module, you need to give, and you're allowing people to plan and apply locally, which is a valid use case even at large scales, because you want to be able to give people the option to manage infrastructure. You want to enable them. If you are having all those resources in one root module, it's not possible for you to separate, hey, application engineers can only manage these resources, production engine or infrastructure engineers, platform engineers can only manage these resources, or they have elevated permissions to manage those, more core fundamental network below the surface level resources. So I think it gets into a fun problem of there isn't the capability to separate across resource lines on who gets what permissions, and that is a core problem when you're running more at scale, when you're trying to manage a lot of infrastructure and you're trying to do least privilege well. It's almost impossible to do with a Terralith.
Right. And even in an automation scenario, somebody has to have permissions to run pull requests and merge those pull requests. And they might be able to, if you don't narrow things down and it's all in one big root module, they might be able to affect change that you don't necessarily want them to.
Yeah, that's another good point. Like, even if you are automating this, it's possible that somebody on the application team adds or maybe an application engineer's machine gets snagged at the coffee shop and somebody decides to deploy a Bitcoin miner. Maybe that root module that the application engineer has access to edit and merge away and get automatically applied, you don't want to give that the permissions to deploy that EC2 instance that you have no idea what's on it. uh,
Right.
so yeah, I think that there's different ways to handle that problem, but the essential bit there is that, hey, if you have everything in too big of buckets, then you can't selectively decide who has access to what within that bucket. And that's the problem.
Okay. Now, one of the things that I'm thinking about when breaking up a Terralith is the really nice and easy to express relationships you have inside the Terralith. And this is probably part of the mapping exercise when you're thinking about breaking one up. But when I build a Terraform configuration, if I want my EC2 instance to refer to a subnet in the VPC, if all of those resources are defined inside the same module, that reference is easy. It's just a standard address. But if I move my network resources to a different separate root module, now I need a way to bridge that gap. So I've added an element of friction to my workflow.
Yeah. Yeah. So you want to be able to reference the infrastructure that you've provisioned at lower levels, right? Like,
Hmm.
you want the ability without having to hard code. And there's a lot of ways to do this. And sadly, some of the ways are just not possible. What we suggest is that you always try and rely on data sources. So a lot of things end up coming down to like, hey, I need to provision this EKS cluster. I need to provision this Kubernetes cluster in the same network that was created for my team.
Mm-hmm.
How do I reference that network, that VPC or security groups or the subnets that it needs to be provisioned in? Well, what we always suggest is use data sources. That gives you the direct line where you can say, hey, let's look up the network that I'm in according to whatever environment I'm deployed in. So let's say, hey, I'm running in dev. I can look up the network for dev because of some tag policy that we have internally. And then you're able to reference that without having a hard-coded reference. And you're able to easily mesh those two things together. There's other ways. There's Terraform Remote State, which basically remote state is the ability to have an output in one root module. And when that root module gets applied and that output gets populated into the state file, you can now use a data source called Terraform Remote State, where you can read that output from a secondary root module downstream.
Mm-hmm.
And what you're then doing is you're creating a contract between those two root modules where you're saying, hey, root module A is going to create this output. Root module B is going to read that output. And whenever that changes in root module A, root module B will then get a plan and applied and it'll update. And you don't have a good way, usually. You do have some means if you're using, good automation tooling to actually express that relationship within your automation tool. But there is no way in Terraform or OpenTofu today to say root module A depends on root module B. Or root module B depends on root module A.
Right.
But that's problematic because you now are relying on this output. So suddenly you have another engineer who changes in root module A the name of that output, and now root module B is broken, or you need to express that data differently, and you now need to update both. So you've kind of created this contract that can get you into a bind. So we usually say avoid that as much as possible and work to use data sources rather than remote state, because remote state will get you into these, you're tightly coupling your root module relationships, and that can get you into a, like, we've seen it go poorly. I'll just go with that. Like, I don't know how to, I'm trying to describe it here. I don't know if I'm particularly nailing it, but there is issues. Yeah.
It makes sense. It's almost like when you're interacting with an API and then the version of the API changes and suddenly all of your scripts break and you're like,
Yeah.
what happened? And it's
Yeah.
because, you decide to accept latest, and because the outputs aren't versioned necessarily, you can't ask for the older version of that output. It's just whatever's in the state file is what you get.
Yeah, and there's some fascinating things that people have done. There was an article about Terraform data contracts, is I think one of the things that they mentioned in the article, but it was an engineer who had built like a pretty sophisticated system around how the remote state boundary between two root modules or a set of root modules should work. And I've read it a number of times. We've shared it with clients, and I'm always like, you could do this. I think it's kind of it's one of these things where, is that the right level of complexity that we want to be working at? Is there other things that we can do to avoid that type of system? I always try and keep it simple. So yeah,
Right.
that's what I think of.
I guess part of that keeping it simple is breaking up your root modules to simpler root modules. So once I've identified that I have a potential Terralith on my hands, how do I migrate some of the resources to a new root module? Because that seems fairly disruptive.
Yeah, it's kind of rough because root modules don't know about one another. So
Right.
we have moved blocks. We have the ability to move resources within the state file of a given root module instance, but we don't have is the ability to say, oh yeah, this root module knows about this other root module, and we're going to move resources across them. So migrations end up being this hard thing. So yeah, we've written an entire blog post on this. We have a nice, very clarified checklist of like how to think about this process. And because we've gone through this multiple times, we really know the deal. My colleague Veronica, she's helped me with a number of these projects, helped my organization, helped our clients with these projects, and we kind of distilled all that information in one place. But yeah, once you figure out those logical groupings of like, hey, we want to segregate our network resources, and we want to segregate our data store resources, and we want to segregate our application cluster resources, how does that actually happen? And what we always suggest to do, and what we've done, is we'll take the idea that, hey, we're going to copy and paste some of those resources that we want to move out to another root module. We're going to create the structure for that. And then what we're going to plan on doing with the newer tools that we have available to us in Terraform and OpenTofu, I believe it's 1.8 is when they started to get really good at this. We have the ability to do looping imports, where you can give an import block and you can say, hey, I want to import resources with these names to these locations in my state file, or these resources or module blocks.
Mm-hmm.
We, instead of saying, hey, we're going to explicitly take resources or representations of those resources out of the state file and move them directly to a new state file, what we do is we import them into the new state file, and then we use removed blocks to remove them from the old state file. So we try and be as declarative as possible. And that's what our article goes into, is really this focus on what we used to do pre 1.0, pre 1.5. We would write migration scripts, bash scripts that would pull both state files and then run a moved command across the state files. And it was really janky, and it was prone to error, and it was really difficult. And what we've now moved towards, and what we suggest, is doing this declaratively, so that, hey, if you have a root module that has 3 instances, like you're doing dev stage prod and you're using workspaces or you're using dynamic backends, then you have the ability to not have to think about, hey, how do I do this imperatively? How do I run the CLI commands that are necessary to get each of these environments spun up? You instead are encoding it directly into your IAC, and then that gives you the ability to review it and make sure it's tested, and you're working through that process iteratively rather than imperative operations, which we tend to fail at as engineers. So that's the way we think about it and how we break them up usually. Yeah.
Okay. So if I'm following your thought process, is first you map out what you actually want to move. So not updating any code yet. This is just a pure like on paper exercise.
Yeah.
Here's what I actually want to move. And then you make use of the 2 special blocks that exist now in OpenTofu and Terraform: import, and for the target new root module, and removed for the existing root module.
Yeah.
And would you recommend to do this in a sequenced way, where I'm not moving all the resources at once? Maybe I'm moving a handful of them at a time from one module to another?
So what we tend to do, and what we suggest to do, is like we've gone the route of, hey, work on your lower environments first. Only have your import blocks work on dev resources, and then remove them from your source root module for your dev environment. And then you're able to like say, hey, how did that go? Did we cause potentially downtime? What did the plan look like? A big part of this is like the validation after the fact. You want to make sure that both of these root modules, they should plan clean. Like they should plan 0 changes
Right.
and 0, things to add or remove. And that should happen both before you start this like migration operation and after. And that's like a critical component that I didn't hit on. But yeah, what you're getting at is right. Yeah, you can think about breaking this up and how you want to do it from maybe you have a small root module to start that you can carve off your Terralith and start there, make sure your process is in place, and then move on to something meatier. And, it's always good to work on resources that, hey, if this gets destroyed somehow, usually it never happens, but let's say we destroy our application cluster. That's way less important to me than destroying my database cluster because there's not data that's associated with that. We should be able to spin that application cluster up, and that we should be able to resume operations without too much of an issue. So thinking about it through that stage effect is definitely something we address in the article, and I glossed over, so I'm glad you called it out.
Yeah. No, I really like that you called out the fact that part of the validation process is that they should both plan cleanly, which means no changes.
Yep.
Um,
You have to
because
deal
in
with your
theory,
drift first. Sorry.
well, expand on that a little bit from the drift standpoint.
Yeah, I mean, I think that one of the things that happens with Terraliths is that it's easy to get into a drifted state because you're
Mm,
managing so many resources in one root module. It's it's either common that you have something on the cloud layer that's like constantly changing, whether to, actually, hey, this is Johnny went into the console and changed something around, or it's something that changes because internally your cloud provider is updating some field, and you don't actually have the lifecycle ignore block on that particular thing. But usually what we've run into with a lot of Terraliths is that there's some fatigue that the team has around drift, and you want to deal with that drift before this migration like begins, because you really need that ability to say, hey, this is a clean root module. This matches what we have in our provision cloud environment today. And then you're tearing that off, and you're one of your big validation pieces is saying, hey, that new root module that we've now imported state into and now is managing those resources that we've provisioned, that's also clean. That also doesn't have drift. That doesn't, isn't causing us any heartache. So yeah, that's the little bit deeper dive. Yeah.
yeah. No, I'm glad you brought that up. That before you even attempt to start moving resources over, you got to run a plan against your existing Terralith and make sure that it comes back clean with no drift, because you don't want to try to inherit that drift and remediate that as part of your migration. Like, keep those two things separate.
Yep. Yeah. It's a thing that gets easier as you do break up the Terralith. So you have to deal with it once, hopefully, and then you'll have one root module where you're like, why is that one always drifted? Oh, yeah, we got to talk to Johnny over in application team B or whatever it is. I don't know.
Mhm.
Yeah.
One thing that I've seen with really large Terraliths is a tendency to add the sort of skip refresh on plan,
Yeah,
and that does make things run much faster.
it does.
But
Yeah.
it also means that Terraform only knows what's in the current state. It has no idea about anything that's changed since the last successful apply.
Yep. Yeah. So, and that can lead to disastrous consequences. So if you do a, Terraform plan, no refresh, like you use the flag. So, and what no refresh does, if in case anybody doesn't know, is that it will basically say, hey, I'm not going to reach out to the cloud about all these resources that you're planning against. I'm just going to take the current state that we have in the state file. That could be a week old, it could be a day old, it could be a month old. But
Mhm.
we're going to plan your code against what we have in the state file, regardless of how old it is. If you plan against it and then you get a plan that says, hey, we're only going to change these things, and then you run Terraform apply auto approve, oh no, you just broke stuff, because the reality is that your cloud provider, the actual resources, the actual state of what's in your cloud could have changed, and
Mhm.
that can result in negative outcomes. So no
Right.
refresh can be helpful. It's a nice thing, but it's also like, you know, part of the reason why we want to break down Terraliths is so we do less no refresh, because we have faster operations. We don't need to think through the idea of like, oh yeah, this usually takes an hour, so let me do no refresh so I can make it go faster.
Right. Well, I guess once you've decided to take on this project, you just know that there's going to be some plans in there, and you're just going to have to deal with that until you actually manage to carve some of these resources off.
Yeah. Yeah. It's this is a process. I mean, I think that for the most part, we're talking about how to deal with it from a, hey, you're already there. And I think that that's a problem that we run into a ton, because particularly for the startups that have just grown wildly, or Folks, infrastructure as code is not all that old, historically compared to everything else that we do. So
Hmm.
there's a lot of practices, there's a lot of things that just people are not ready, or they don't know. They jump into it and they don't realize, hey, this is a thing that we should avoid. So we see it a lot with people. Great way to avoid it is, hey, think about breaking up your infrastructure into logical groupings that make sense so that you can easily manage them for your size business. And I think that what we typically look at that from the perspective of, there are like functional groupings where you can say, hey, we have networks, we have data stores, we have application clusters, we have individual groups of things, monitors if you're doing observability as code. And then we have like fine grained. And we usually say, hey, if you're a startup, go with the functional side of
Hmm.
groupings where you don't need to break it up that deeply. You're not going to run into problems, and you shouldn't really focus too much on being ultra fine grained. But if you're at if you're at a size where you have a considerable platform team of 10 engineers, you're servicing hundreds of application engineers, you definitely want fine grained, where fine grained is like, hey, I have not just a network, but I deploy a VPC as its own thing, and then I deploy a VPC peering operation as its own separate thing. And those, you want to break things down into fine grained, because you're gonna run into projects that you're gonna need to compose these different root modules and basically use them as building blocks to create the infrastructure that you want, and that
Hmm.
ends up being the better path, right? Yeah.
I so when you're planning out your infrastructure as code, I mean, I guess planning is the operative word here,
Planning's a good word.
is yeah, you actually want to take some time to do some architecture, design, and planning before you just start dashing off root modules, because that could help you avoid getting into this Terralith situation in the first place.
Yeah, definitely. And the way that I've described it this way in a LinkedIn post recently, and I think it's accurate, is imagine you were to build a new application code base today and you're using some SQL database.
Hmm.
Would you put all of your data in one table? No, right? Like, you would not do that. That's not the way we do things. And it's a very similar type of idea here. Don't put all your resources in one state file. That's akin to using one table for all your data in a SQL database. You want to be strategic about how you break that state file, or how you break all that state up, so that you're operating across many tables. And yes, linking and doing joins now is a thing, and now that's painful, but it is also way more sustainable in the long term.
Right, right. As each of those tables grows independently, you'll be able to handle that scale and those changes.
Yeah,
And yeah, as your team grows, as your organization grows, and your infrastructure grows with it, you'll already have set good standards and practices in place to help you with that growth.
exactly.
Now, the flip side of this is, how much is too much breaking up? How
Yeah.
minute is too minute? Because we are adding operational overhead here. We have to stitch these various root modules together. And if I go overboard and there's just like two resources in every root module, then I've got a nightmare when it comes to updating repositories and all that stuff. So, like, where would you draw the line that, okay, this is a good size, don't make it any smaller?
I think what I described as fine grained is definitely the smallest we go. So fine grained is, hey, we're deploying an individual service, and let me be specific. Let's say you're deploying an ECS task, an ECS service, something like an API.
Hmm.
We have a ECS service root module. And we wouldn't go and deploy the ECS task definition as its own root module. We wouldn't then go and deploy the ECS service as its own root module. You can group those things, right? And you want to group some set of resources that is logical to your organization, so that you can move quickly and you don't need to, have too many dependent root modules that, reference one another and create you headaches. I think that's like the quick answer. The longer or like more abstract answer to this question is that yes, there are big downsides to this. I think Malcolm from Terra Team is a friend of mine. I really like the guy. We've been having this conversation back and forth. I know you know him as well.
I've seen it.
Um, he's thinking in the abstract, and he always questions this idea of like breaking up Terraliths. He's like, why do we do this? We have the ability as software engineers to like handle these problems. And I love the way he's thinking about it because he's really right. Like, I really wish that we didn't need to break things down as much as we do. But
Mm,
with the ergonomics of the tools that we have available to us today, we need to. Like, at the end of the day, there isn't a good way to say this small piece of the infrastructure that we're planning needs to be planned and applied, and it shouldn't lock the state file, and it can be run in parallel with these other pieces. We don't have the ability to take the graph that Terraform and OpenTofu create for us and say, we have a subgraph. So him and I are actually
mm.
talking about, hey, how could we improve this? How could we make Terraliths better? And we're going to submit some proposals in the coming like month or so. But what I'm getting at there is that the trade-off here is that you do need an orchestrator. You can't create 50 root modules for a team of 3 platform engineers and expect them to be planning and applying those all locally. They're going to go insane, and that's going to be their every day, right? Is just planning and
Right.
applying. You do need some level of automation. You do need a tacos tool like Spacelift, Terraform Cloud, M0. All of those tools are really good. There's so many tools out there now. Like, we always suggest don't write your own custom pipelines, because particularly when you're automating these things at these level, when you have fine-grained or functional, however many root modules you have, rely on the people who have built software to do this instead of trying to think you can reinvent the wheel. Well, I feel for people that do it because their heart is in the right place, but I always suggest write less custom code when you can. But
Right.
yeah, that's the trade-off, is that you need to orchestrate these and automate them well.
Mhm.
And that is an important piece of breaking up a Terralith, is that maybe that's like something we de-emphasize. It's the other part of like what we help clients with a ton. And it's really important. It's really important to have that buttoned up so that you can say, hey, we're going to take this Terralith that we do as one operation a day and we're going to turn it into 10. You can't do that without some level of like, oh yeah, and this is going to be sustainable because we automate. Yeah.
Right. What is your general feeling on the various stacks and implementations out there? Because HTTP Terraform has a stacks thing in beta right now. I think it's still in beta. You've got TerraMate with their stacks. You've got TerraGrunt, which I don't know. I don't remember if they call them stacks or they call them something else. But all of
Yeah.
them have this idea of being able to compose multiple root modules with a single orchestration tool that sort of wraps around or enhances Terraform and OpenTofu. Do you feel positive, negative? Don't want to dip your toe in that?
No, I think it's the wrappers and orchestrators working to fulfill a need that we have, right?
Mhm.
I don't think any of them are perfect, and I think that Terramate has ways to handle this problem, but like the term stacks is so overloaded.
Oh,
It's
I know.
awful. It's such a struggle in the industry. But like their term stacks is like, I think they call root modules. I think their like version of stacks is just a root module instance or a root module. But they do have the same capability. So like what I think about it, I think that it's a useful tool, and I think when you're orchestrating a ton, that it's something that you do end up needing. And I wish we had more of a Terraform Cloud is an interesting one, because I don't want to talk I don't want to talk smack, but like they only made it for Terraform Cloud, right? So it's like,
Yeah.
hey, this thing doesn't actually benefit Terraform users unless you're paying a good amount of money. And yeah, I think that I wish we had. I've said this for a long time. This idea of I wish we had a DAG of DAGs. So,
Yes.
and that's kind of what they're trying to do with the different implementations of stacks and kind of creating dependencies between root modules. And I don't know if I've seen one where I'm like, oh yeah, that's it. That's the one that I'm like, yeah, all in on. And I think that we need to hopefully make some implementation changes at the root of the tool. Like, let's not leave it up to the wrappers and the orchestrators. Let's build it into the tool so that we can say, hey, we can handle a much bigger state file, and we can delineate what are the subgraphs, explicitly saying, hey, this our network resources are these set of resources and child modules within this larger Terraform root module, and we can plan and apply those and not cause the Terraform state file to get fully locked. We only lock it for those resources. And then we can use a different role, so we can handle the role-based access control problem. And
Mm.
yeah, I don't know. I think that there's interesting things that we could do, but it's all theoretical and, trying to innovate within the space rather than rely on what we have today in terms of wrappers.
Yeah. My experience with how HCP Terraform stacks approached it is they introduced a concept of components, which are almost like each component is its own root module,
Hmm.
but it does like build a graph that includes all the components. But like you said, unless you are running HCP Terraform, you
Yeah.
don't get the benefit of that solution. And I would love to see, like you said, just a standardized way that goes back into the tool itself, to have that innate understanding, as opposed to using a wrapper or an orchestrator to build this sort of a DAG of DAGs, as you
Yeah.
said.
Yeah. That's what I want. That's what I want. We'll see when we get there. I think it
I
needs to
want
be
that too.
within. Yeah, I think we all do. Yeah, it's not a debate. It's a good thing. It would be a good thing. Um,
Sure.
one day, the future
One
of
day.
infrastructure as code. Yeah.
All right, Matt. Well, this was fascinating. If folks want to hear more from you and get more of your fun ideas and opinions, where's a good place to find you?
Yeah. So always connect with me on LinkedIn. I post very regularly. That is like one of the places that I've met a lot of really good colleagues. I think yourself included.
Could be.
People we met at HashiConf, actually, just thinking about it. But yeah, LinkedIn, definitely a good place. I have a newsletter. You can find that at masterpoint.io. Again, all infrastructure is code focused. We just started creating video content. Going to be a slow roll, but I'm excited to like create some videos about some of our best practices, things that we really feel are important. You can find that on YouTube at MasterPoint Consulting. And yeah, just check out our website, masterpoint.io, and you'll find all the things. So
Awesome.
yeah,
Well, thank you, Matt, for taking the time to talk with me today. I
thank you,
really
man.
appreciate
Always
it.
a pleasure. Yeah,
Yeah.
thanks, man.
All right. Yep. Take care. Bye.
Cool.
I found that conversation really interesting in the sense that we learned what Terraliths are and how to avoid them or break up existing ones, but we also discovered that there's some debate and nuance on whether Terraliths are actually bad or if they're just something that you might want to avoid. I think the key thing is understanding what the pitfalls might be and determining for yourself and your organization whether it makes sense to deal with those issues and keep all your code in a single root module, or if it makes more sense to break that code up into multiple root modules. But I'm curious what you think. Please let me know down in the comments or reach out to me on LinkedIn. That's going to do it for today's Terraform Tuesday. Thank you so much for watching. Until next time, keep calm and terraform on. I was going to use the 2001 Space Odyssey music, but I'm not sure if I can get it with licensing and if YouTube would like give me strikes. So I didn't. But just imagine it in your head.